तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
We were analyzing waveforms for state machine earlier, and we had also seen parallel to serial converter in which we had missed two of the waveforms. So, first we will cover that before we resume state machine. And just to recollect what parallel serial to converter is, we have a reset, then you can set data through this and asserting load. Thereafter you can give a shift control, and this shift can be either left shift or right shift, this being 1 for right, and that's it's being reckoned at positive edge of the clock, and you have an output corresponding to the serial stream, bit stream as such, right at data out, and when it is valid will be indicated by this data valid signal, and once all the 16 bits are sent out serially over this, an end of conversion will be generated. And looking at this waveform, first we will have a this we have already looked into. I just zoom here. First I will explain here and then zoom. So, we mentioned that it is basically a shift register as which has been loaded with 1010 prior to that, that is right here, with the set data being put over here with load asserted. You can see that load is high here, and so shifting starts right at this point once the load is complete, and simultaneously you also assert say right here, and what happens after this, this is 1010 pattern shift register which will be shifted 1 bit per cycle at positive edge of the clock, that is here, and you can there is also a counter which will keep track of the number of bits sent over the serial channels, and this we start with 16 here, and then it starts decrementing for every time a bit has been sent, and the first bit that is being sent here is say 1010, it becomes 010, that means this has been right shifted, and so the very first bit on the LSB will go out as data out, that is what you have it here. One minute, this is, let us have a look whether it is this is a right shift, right. So, if it is right shift, is this right? First data out is 0, not 1, as I mentioned, it is here, right here. So, first bit you would see is, I will just zoom this. So, this is the shift register, this is the counter, and data out, data valid and end of conversion respectively here. So, all of them are 0 and right here you get the very first bit is for this and that is the first bit here, and next bit is 1 and that is what is here. 1 minute. I told the wrong thing. The data out is this. Yeah, right here. So, 0 is first here, then 1 here. Hereafter it should be 0, 1 and so on in a toggling mode. This is the very first waveform. We had already had a look into this. The second one which we did not have last time is this, and this is towards the end of the right shift, this one, and I will zoom that here. So, set data is this, and this right shift is still high and shift has been asserted high, asserted, and this counter has come down to 4 here, 3, 2, 1 and so on. So, you can still see that some of the patterns are still here 1 0 1 here, and once you right shift this one gets dropped. So, 1 0 here, and you can see that data out is going alternatively low and high, and all through data valid is high, and end of conversion is 0 because all the bits are not serialized. Now, coming to this end 1 0 1, then 1 0 is a shift register, and then comes 1 because 0 gets dropped, finally 1 also gets dropped. So, ultimately it will be 0 here, and the last bit that will be is this one, last is we started with 1 0 1 0. So, last bit will be the MSB. So, naturally that should be the 1 here. So, earlier we saw that, okay. And now you can see after this is over and all these transactions are taking place at the positive edge of the clock. You can just see here, every time it happens, positive edge here, positive edge here. You can see this, and finally an end of conversion is asserted here. So, this is the last for the data, therefore data valid goes low. So, the last two are data out here and data corresponding data valid, end of conversion. So, this is for the right shift. Similarly, for we can have the left shift here, and straight away we will go into the waveforms of interest, and this is once again shift register here. Before this I will just show where the loading is. Now, this time we are not loading, this is data loaded, you can see set data, and what we load now is 0 1 0, just opposite of the previous content, and this is the load asserted, and shift starts being active right from here the moment it is loaded. So, shift register must start with this value to start. So, you can see same 0 1 0 pattern here, and once again this end of conversion, this is the previous end of conversion which we had processed. So, the moment you load a fresh data, that is reset. So, you had to all intricate details you will have to take care. So, while designing systems, and data valid was deasserted in the earlier cycle. So, it will have to be asserted here the moment data starts flowing out, and once again the parallel to serial conversion takes place, but this time it is left shift as is here. So, it was 1 here for the earlier thing, it becomes 0 here. So, implying it is a left shift. So, if it is left shift, 0 must go through first here. that is data out is here. So, 0 is there and data valid is asserted here, and count keeps on decreasing, and you can once again see 0 1 0 1 again, same bit pattern, and it keeps going. So, finally, we will have one more waveform where you see the end of this left shift. So, you can see again it was at 4. So, it is left shift. So, what you have is one must get, now it should shift in this fashion. So, one must get dropped. So, and one must also go through the output, and this is taking place here, because shift happens here, but it will get reflected only at the positive edge of the next clock. So, and so on it goes. You can see here this 0 1 comes over here, and all vacated bits are all filled with zeros. Then again this one will go through to the MSB, and again you can see the data out toggling, and finally it lands up at 0 here, and we started with 0 1 0 1 and so on. So, the very last must be 1, because it is a left shift in 0 1 0 1 0 1, right. So, the last bit will be 1. So, after 16 shifts here, and once again data valid goes low and end of conversion is activated here, and this completes the parallel to serial converter, and we will go on to state machine as it. We are looking at the waveforms for state machine, and in this we have 4 states S0 through S3, and there are 2 inputs, and based on which there will be a transition made right from one state to another. For example, if it is in 0, it remains at the same state, and for each of these states Z0 through Z3 are mere lamp indicator, and the actual state is 0 0 1 0 and so on. So, looking at the waveform for this, we have here So, we had actually looked at this S0 state earlier, and we will just quickly go through that. And here what you see is this is initialization phase. So, when reset is applied, and inputs are here, and these are all the state outputs here, and actual state itself is here, and so this is a plain reset state. There is nothing much to convey except that all the lamps are 0, and at this point of time the real S0 state comes into play, because reset is removed, and following positive edge of the clock only it starts getting activated, and right at that point of time S0 it enters the S0 state and activates Z0 there, right this. So, here, so next one is we are so long as in 1 is 0, it continues to be in S0 state. In fact, that is what you have already seen, and from this it can go to the next state provided in 1 is 1, that is it goes to S2 state, and in this case you can just see here this is S0 here, and it is going to S2 state here, and in S2 state although it enters the state right at this positive edge of the clock, actual lamp output will go only the next positive edge of the clock right here. So, you can see for S0, so what is this is S2 here, right, this corresponds to S2 state, and so on it goes. From we will have a look at the actual state. If in S0 you can go out to S2 state provided in 1 is 1. So, let us examine in 1. So, it is 1 and irrespective of in 2 being any value, and it takes you to the next state S2 here, and this lamp, corresponding lamp also lights up here. And so, now let us see what happens here. Now, at this point of time you can see some other Z1 going high. Let us verify whether that is right. So, in this case what we have is in 1 into, there is a change of state here. Earlier it was 1, now in 1 goes to 0, and let us see what happens here. So, if it is 0 and into goes high, so 0 1 we had to consider in 0 1 state. So, right here Z2 is 1 here, and so in 1 is 1 here, and at this point of time it is 1 and 0. So, let us find out what it is. So, if it is 1, that is in 2 is 1, is it?
In 2 is 1, in 1 is 0.
Okay. Now, let us first, which one, if in S2 state, if in 2 is 0, it will take you to S1 state, otherwise it will take to S3 state, just remember, because so in I think it is better if you make slightly compare the two. This may be pretty difficult to remember. So, we are in state 1 0 here, right, and corresponding in out are these two are in out. So, if you see this in is 0 here, so we are in S1 state. Oh, we are at the looking at the wrong state, I think. So, we must have looked here. S2 is the next state here. So, in this state, so what is in 1 is 1 and this is 0. So, in 1 is 1, in 2 is 0 in S2 state. So, in 2 is, so this is the so we will go rather slowly because it is quite intricate. So, we will have to go very slowly and then only you will understand that. So, we are in S2 state. So, in S2 state, that is this state. So, what matters is only in2. So, here in2 is this one. So, it is in 0. So, that means, so we should in2 is this. So, it should take you to S1 state. So, that is what it is, right. And here, are you able to see this waveform or you need a zoom?
No.
So, you can next we will go from 0 1 state. So, that is in 0 1 state, and in this these are in 1 and in 2. In S1 state in 1 is 0, this is 1. So, so long as it is in 0 1, it continues to be in 0 1 state as per this. So, in 0 1, so long as it is 0 1 here, it continues to be in S1 state. So, on the other hand, if I2 is 0, let us see what really has been put. This is what you have. It continues to be in 0 1 state, and here it is going to 1 1 state. So, let us see the corresponding IOs. So, the IOs are these two, right. Now, it is 1 0. So, let us see So, in this state, so these two are in S1 state, this over, okay. We had to see here, this is 1 and this 1 I had read it, okay, I read it as 1 0, it is actually 1, you are right. So, for 1 1 automatically this is satisfied, so S1 to S3 it goes to, so that is what you see here. So, and that is for so in the next continuing waveform we were here 1 1 and now corresponding in 1 in 2 is, so once again we will just reduce this. So, we are in S3 state now and that is this one, and corresponding inputs are this is now the changed inputs 0 here and this one is 1 I think, right. If it is 0 1, so it should take you back to this S1. If it is 0 1, it should take you back to S1. That is what you see here. I will just from 1 1 it takes back to 0 1 state. Then at 0 1, now again inputs are, this is 1 isn't it, 0 1 now, right. 0 1 would mean continuing the same state here, and next in 0 1 once again these inputs are changing to 1 1 1 isn't it. So, it will take you back to S3, we are just going to and fro, so we will move forward. So, in 1 1 state let us see what happens, and here the two are again this is the change, right, and in order to go to this state. So, if it is both are 0 0, both are 0 means, I mean what matters is only into being 0 here. So, if into is 0, you go back to state 0 right here, right. So, what we have seen is this here and then to and fro we went and then go back here. So, what we have to see is this path, I think that alone remains to be seen. So, let us see the next one. So, in this the one we have seen already. Okay. So, now in we have to look at S1 or S3. S3 we have already seen. So, that means S naught condition we have to analyze from. Yes. I think this one, it is here, I think fourth waveform, right. So, in S naught state what is happening, both are 1. So, right. So, what is of interest actually is I think in 0 being 1, right. So, here, so we are going back to S2 here. So, in 1 alone matters now, from here it will go, it has to necessarily go through this state. So, it has to go to S2 state here, that is what is happening here. In S2 state, so in 1 both are 1 here. So, where should we go, both are 1, right. So, it is going to S3 state. That is what is happening here, and continues to remain in S3 state so long as the inputs are same, and in fact it is same right up to this, and then finally it goes to 0 1 here. So, that is for 0 1 transition. So, let us see that. So, we were in this, right. So, 0 1 would take you to S1 state. So, that is it. This one, the 0 1 here, right, and I hope you have kept track of this all the LEDs for Z0 through Z3. In fact, I forgot to mention, but you can see one of them you can verify here. So, for 1 0 state, same thing you should get here, Z2 must go. So, 1 0 is 2, so Z2 must go high. So, this verifies at random, and finally we have one more waveform in the state machine. I think this is the path we have not covered, I suppose. Let us see whether it is. So, let us say from S1 to S1 state. So, and then from there it is returning to 0 state, and let us see the condition here. And, so, what is this here? 1 1. So, input is 0 1 here. So, in 1 1 state 0 1 we have to look into this 1, is it 1 1? Yeah, it will go to S3. Yeah. Now, where are we? We are in 1 1 state. So, 1 1 state it is 0 1, right? 1 1 state it is 0 1. 1 1 is this state, not this, right? With 0 1. So, it takes you to S1 state. So, that is what it is, right. In S1 state again it is continuing to be same, and therefore, it remains in the same state, and once again at this point of time there is a change in IO inputs again. So, it is here 0 0. So, if it is 0 0, it should naturally take you to 0 0 state, and here in this earlier thing it was 1 1 here. So, the Z3 output is set here, and it will change state for this state only at the following positive edge. That is why this is always delayed by a clock pulse, right. And earlier for S1 state it was this is the S1 state, for that corresponding Z1 is lit. So, you can always see it takes effect only at the following edge, because only after entering this state this output can be set. So, this happens, transition is happening from this state to this state only here. So, naturally it is that state output must get reflected only at the positive edge of the clock, that is why this is there. So, any sequential machine will have this always delayed by a clock, and that is not a handicap, because we always have a very high frequency for the clock, and no user can notice the difference, and nothing erroneous operation can take place, because the whole thing is synchronous as such. And here, so that is what we are from S1 to 0 0, provided both inputs are 0, and you can see that here, right. In fact, what is of interest is only into being 0. So, in S1 if into is 0, it will automatically take you here. So, we have seen all the paths. So, only thing we went to and fro, that is why it has confused a bit. So, otherwise you have verified that the whole functionality is intact. So, next one we will consider is pattern sequence detector. In this detector we have once again 4 states, and we have this as input, and corresponding output is this. So, we need to detect a pattern 0 1 1 0. So, we will start with this, and suppose if it is 0, it will go to this state. So, because it is 0 in this state, and then as per this we will be going through. So, we will once again go through the waveforms for this. We will have a look at the pattern sequence detector waveforms now, and this is what we have already seen, and the very first waveform here is we have very few signals. There is a reset clock as usual, and this is the input pattern that we apply, and final output pattern emerges from out, and in what state it is indicated by this PSD underscore state. And to start with, we initialize to 0, and the pattern here we had deliberately put it as 1, just to see that the very first 0 is not encountered to start with. So, there is not much activity in this first pattern as such. So, that is what here. So long as it is 1, input is 1, it continues to be in this state. And now next is we have the second set coming over here, and you can see this from state 0 we are moving on to state 1. Let us see what happened in the meanwhile. So first what we have is in being 0 now. Earlier it was 1. Now the very first pattern that is coming is 0 here, and at every clock transition it is being reckoned, and here the actual input is applied little offset, you can see this. So because when we come to positive edge of the clock, it must see a stable value at the input. So that is the reason why we have taken care in the test bench which we have seen earlier. And so now you can see this bit pattern that is being applied from the test bench. So to start with it was 1, now comes 0 here, then 1 here, once again 0. So naturally we will continue to remain in the same state. So that is as per this. So long as it is 0, so we will continue to be, it was 0 there, and it went to state S1 and then continue to be in S1 so long as 0 is input, and corresponding outputs are all this here. So what is indicated as out in the waveform is precisely this, and in is this. So we continue to be here in S1 state, that is here. No, that is here. It is already in S1 state here. So now we have skipped this actually. So what happens here, if 0, this is 1 to start with, and 0 1 has been encountered. So if it is 1, the input is 1, this is input, right. If it is 1, this is the output. What in state 1, if the input is 1, what happens? In state 1, if input is 1, it goes to state S2, and if it is 1, it goes to state S2, and now once again we change the input here from 0 1 to 1, right. This is what we applied from the test bench. So what happens to this? If it is 1 in state S2, in S2, if it happens to be 1, it goes to S3. What is the problem? It is not going. It is 0 here. What is sensed here will be applicable only here. Here. Let us analyze here that we will analyze from this S1 when input is 1, let us consider that. In S1 when input is 1, so it is changing state here. So subsequent transition is owing to the input here. So what does it sense here? Is it a 0 that is to be sensed or 1 that is to be sensed? In S1 the question is, should we take 0 for this state or 1 for that state? So let us examine that. See, in S1 state what we have here, S1 state, if it is 1, it should go to S2, right. Otherwise it should remain right there in S1 state. Let us see what is that. If it is 1, it should go to the S2 state. See, in S1 state if it is 1, that is here, then it should go to S2 state. So that means only at this positive edge this is being sensed, right, and this is the result of the previous one. So whenever there is a positive edge or the clock encountered, only at that point of time it is going to check the input here, right. So, now at 2 let us see, put the same condition. So, at 2 naturally it is not this one, but this, yes.
Go back to the first beginning. At the positive edge of the clock, at the positive edge of the clock.
This one?
Yes.
Yeah.
The input is 0.
0.
So it goes to S1 state. Shall we see?
This input. It was in 0. This state you want or this state?
No, I want to see when the input is 0.
No, it is this transition. This is 0 is applicable for this state. From 0 state, if it is 0, is it?
Exactly.
Let us see that. We are in S0 state. Yes. If it is 0, it should go to the S1 state, right? If it is 1 only, it will remain there. So it is here. So is that all right? Okay. So where are we now? In 2, right? At this state. So at this state, what counts is not this one, but this 0 prior to the positive edge clock transition, right. So at this point of time only this input is taken and processed, and this corresponds to this state, and as a result of which you get a new state here. And let us see that in state 2, when input is 0, it should go to S1. In state 2, if input is 1, is it 1? 0. Okay. If it is 0, then it should go to S1 state. Is it okay? Okay. Right? Input is 0. Yes.
I think the input is sensed at the positive edge of the clock,
yes,
as well as the output changes simultaneously, immediately.
No, the output remains constant 0. We have not encountered 0, 1, 1, 0 at all. I mean, this state. Yeah, state will state is the first thing that will happen, right? In state machine we have already seen the output is dependent upon the actual state. So unless you go into that state, there is no question of that particular output being effective. Right. So it will take place only at the following clock pulse. So that is what happens here. So is this okay? Transition from 2 to 1, and that is what we have seen. So then we will see in 1 this input is continuing to be 0, right. So again this is the edge that is being sensed, I mean sensing the input here. In state 1, if it is 0, it should continue to be in same state. In state 1, if it is 0, it should be continuing so we went from to and fro here, right. So once again possibly we will go back here, let us see that. So that is when in 1, now what happens to input, it is 1 now. So if it is 1, from 1 to 2 it is making a transition. In S1, if it is 1, it is making to 2, and in 2, I think this is the end of that this current waveform. So we will invoke next one. So in this case we start earlier we ended up with 2, isn't it? So from 2 what is happening? It is 1, right. So this is the edge, right. The input is 1 at 2. At 2 the input is 1, so it goes to S3, and does it go to? Yes, S3, and in this condition input is 0 now, this the edge that, and from 3 it should go to 1, from 3 it should go to 1, right, provided input is 0, is that correct?
The output becomes 1.
Yeah, here becomes the output, right, this is the output. So you can see now. So we are in state 3. So you can see once again it is taking place only all outputs take place only at the following clock edge, right. being synchronous machine. If it is Boolean expression, then it would have taken immediate effect, right. So, being a sequential thing, it will always take place only at the positive edge of the clock. So, the state itself is changing at this positive edge. So, its corresponding output will get reflected only here, because it has to wait for entering the state only at the next positive edge. It has just entered the state, right. That state will be processed only at the next clock edge. Only after you process for that particular state, you can get the output. That is why it is happening. Are we clear with this? No. So, I explained earlier. So, state changes at this point of time, but this output is dependent upon this state. So, it has just changed here, it has not yet got stabilized, it gets stabilized only at the this point of time. So, only that because this basically a state machine, it functions from clock to clock, not in between. So, what you have changed here, you have to wait for the next clock to arrive, then only this corresponding state will be actually processed. So, if you look into the source code, Verilog code, you will see that. So, we would have put always positive edge clock. So, only at the positive edge clock all this happen. So, this was earlier in second state, at that point of time only at this stage it is taking from 2 to 3, and right at that point whatever is the actual input here, only that is being taken and then processed accordingly. So, so in order to enter this here, you had to satisfy this previous condition. So, also here. So, in order to enter next state, you had to create favorable condition for the input, then only it will go into the next one, and only after touching this, although it is changing here, it is actually the processing takes place only at this point of time, right, as far as the output is concerned, because the output is also dependent upon the positive edge of the clock. Always at positive edge of the clock in state S3, you set that particular output, right, it says here. So, that means it can take place only at after 1 clock delay. Are you clear?
It changes from state 3 to state 1 only when the input is 0, isn't it?
Yes, here it is 0.
But that input arrives so far.
No, input is changed here, right. So, we are changing because we have the a priori knowledge that it will change from this state to this state only at the positive edge. So, before this you are free to make the transition either here or even here, right, even here soon after this, right. So, anywhere you can make the change. So, I so happened that I put it here, that is all thing. So, whatever you make when the clock strikes, it plainly looks at the input, whatever is input it will go as per that. So, for this state only at this following clock edge processing will take place, that is what I want to impress upon you, right. So, next is we have already gone from third state to 1 state, and now let us see 1, 2 and 1 here. So, for 1 what is it that we are looking into? So, it is 1 here, this is input here. So, for earlier thing we had sensed this as 0, now here at next positive edge only you had to see. So, now it you will be sensing 1 for the input in state 1. So, let us have a look. In state 1 if it is 1, so it should take you to S2 here. So, we had gone to and fro earlier, we are coming back, right. So, that is what it is. So, if it is 1, what happens? From 1 to 2 it has gone. In 2, now again 0 1 1 0 has bit pattern has been encountered, that is why at last 0 it goes 1 here. So, this is the corresponding output. So, whenever 0 1 1 0 and even in a recurring fashion you should have 1 here for corresponding to that, and in 2, in state 2 we are analyzing, isn't it. So, in state 2 it is what we sense here is 1, in state 2 what we are sensing is 1 and it goes to S3, is it correct? It is going to S3, and just keep track of the pattern that we have already encountered 0 1 1 0, now 1 has come. So, again you see 2 1s are there. So, that it is even the last pattern also is taken into account. So, 0 1 1 again, once again you see a 0 here. So, promptly goes the output high here, right, and from third state you should finally, this what you have seen here, finally it should go to 1 state, provided this input is 0 in third state. It is here, if input is 1, it should go to, what is it, made a mistake, oh here, if input is 0, it should go to 1 state with input is 0, and the output is 1, that is what we have here, right. So, we have one more waveform before we wind up. So, we were in state 1, and now what is happening, the input is 1 here, and which state was it? 1, right. In state 1 input is 1 1 you can just remember, in state 1, right, then 1, yes, input is 1. So, we had taken this path, we have gone already here. So, we are taking the path once again here. So, S1 to S2 should go provided input is 1, right, S1 to S2 it has gone provided input is 1, right, and here again 1 here, right, again you see, notice this pattern 0 here, then once again 1, then one more 1, again 0, isn't it. So, the output is also correspondingly 1. So, you can see 2 to 3 transition here. In S2, if it is 1, you go to 2, you are in S2. So, if it is, this is 1, right, is it correct? 2 to 1 to 3, and next is from 3 you have to go to 1 provided it is 0, 3 and 0. In state 3 input is 0, right. So, it should go to S1, is it going there? Yes, right. In state S1 this only produces that 1 again, right. In state 1 we had to and with the input 1, state 1 and input 1. State 1 and input 1. So, it takes you to S2 here, right, and in S2 input is 1, it should go to 3, in S2 input is 1, it should go to 3, and in 3 input is 1, and in 3 input is 1, it should take you to S0, is it going to S0? Yes. This completes both combinational and sequential circuits waveform analysis, and we are actually winding up Modelsim simulation, and in the next class we will summarize all the commands so that it will be a ready reckoner for you. Thank you.